Hey everyone! Today we're going to be answering the question, how does an electric motor work? This is actually quite a tricky question to answer as it involves a lot of different topics, such as electromagnetism and physics. But don't worry, I will try my best to explain how an electric motor works in the simplest way possible. The type of electric motor that I will be explaining today is called a DC motor because it runs off of direct current electricity. The kind of motor that you typically find inside of things like toys, CD players, or even inside of a computer hard drive. Although these days, many devices use alternating current instead of DC. There are still plenty of devices around us that use DC, and so it's important to understand how a DC motor works. A DC motor has two main parts, a stator and a rotor. The stator is basically the outer part of the motor that stays stationary, whereas the rotor is the inner part that spins. Now, in order for the rotor to spin, we need to put some current through it. We do this by connecting a power supply to two of the four ends of the coil. If we turn the power on, then current will flow from the positive terminal of the battery into one side of the coil, and then out the other side and back to the negative terminal of the battery. You can visualize this with the red arrows here. Now, what happens when we put current through a wire? Well, if you want a more in-depth explanation of this, then watch my video on electromagnetism. But basically, when current flows through a wire, it creates a magnetic field around that wire. So because we have current flowing through our coil in this direction, it creates a magnetic field in this direction. Due to the shape of the coil, this magnetic field is concentrated on either end of the coil, creating something called a north pole and a south pole. The strength of this magnetic field depends on how much current is flowing through the coil. The more current, the stronger the magnetic field. If we place a compass close to our coil, you will see that the needle aligns itself with the magnetic field lines. Now, as mentioned earlier, we have two poles here, a north and a south. In reality, these magnetic fields extend all the way from the South Pole to the North Pole. However, for simplicity, we are only showing the magnetic field at the end of the coil. Now, if we were to take the compass and move it further away from the coil, you would notice that the compass needle starts to align itself with the magnetic field lines of the Earth. This is because the magnetic field of our coil becomes weaker the further away you get from it. So, as the Earth's magnetic field is much stronger than our coils, it eventually dominates over the compass, causing it to align itself with the Earth's magnetic field instead. Now, the next thing that we will need is some permanent magnets. These will be used to interact with the magnetic field created by our coil. Now, you might be thinking, wait a second. We are creating a magnetic field from our coil, and these are permanent magnets, meaning they already have a magnetic field. How are we going to put them together? Well, the key here is to remember that opposite poles attract and similar poles repel. So because we have a north pole and a south pole, if we were to bring a magnet close to the north pole, it would be repelled. But if we were to bring it close to the south pole, it would be attracted. So let's say that we attach a strong magnet to the outside of the motor like this. Then if we move the south pole of our coil towards the magnet, it will be attracted towards the magnet. However, if we move the north pole towards the magnet, it will be repelled, causing the coil to spin. Now, of course, we could just flip the magnet upside down, so that the north pole becomes the south and vice versa. But then if we did that, the north pole of our coil would be attracted towards the magnet instead of repelled, meaning that the coil would spin in the opposite direction. And that's not what we want. And so in order to make the coil spin in the same direction every time, most motors will have their magnets arranged in a specific pattern. For example, the most common arrangement is to alternate between north and south. This means that no matter which pole of the coil we approach with a magnet, it will always be repelled, causing the coil to spin in the same direction. Now, we could attach the magnet to the coil and spin it manually by rotating the magnet, but that defeats the purpose of having a motor. The whole point of a motor is so that we can hook it up to some sort of power source and have it spin automatically without anyone having to touch it. And so instead we have the magnet attached to the stator. the outer part that stays stationary. Whereas the coil is attached to the rotor, the inner part that we want to spin. But right now there is a big problem, and that is that the coil comes to a stop after spinning a bit. This is because gravity is pulling it down. And in order to overcome this, we need to add a spring like this that pulls the rotor back up. By doing this, we essentially create a situation where there is a constant downward pull due to gravity and an upward pull due to the spring. The motor works by shifting the balance between these two forces. When the north pole of the coil approaches a south pole of the stator, it's attracted and moves downwards. This reduces the tension in the spring, and as the coil continues to spin, eventually the south pole approaches a north pole of the stator, which repels it, moving the coil back up. This increases the tension in the spring until eventually it reaches the top again, starting the cycle all over again. Of course, we need to make sure that the spring isn't too strong, as if it was, then the coil would never fall down due to gravity. But we also do want the spring to be too weak, as then the coil would just constantly be falling down. So it needs to be just right in between. Another important thing to note is that we need to make sure that the friction in the motor is low enough. Otherwise, the unbalanced force caused by the repulsion and attraction would never be able to overcome the friction, meaning that the coil wouldn't spin. Now that we know how the basic principles of a DC motor work, let's quickly go over how to calculate the torque produced by the motor. Torque is basically a fancy word for rotational force. So the higher the torque, the faster the motor will spin. The equation for calculating the torque of a DC motor is this. As you can see, it depends on three things: the strength of the magnetic field, the number of turns in the coil, and the current flowing through the coil. The reason why the torque depends on the strength of the magnetic field is pretty obvious. The stronger the magnetic field, the more torque is produced. But why does the torque depend on the number of turns in the coil and the current flowing through it? Well, the strength of the magnetic field produced by the coil depends on these two factors. The more turns in the coil and the more current flowing through it, the stronger the magnetic field, and therefore the more torque is produced. In real life, there are lots of ways to increase the torque of a motor. One way is to simply increase the number of turns in the coil. Another way is to make the coil longer. A longer coil means that the magnetic field lines will be more concentrated at the ends of the coil, making the magnetic field stronger and therefore producing more torque. A third way is to use a different material for the core of the motor. By using a ferromagnetic material such as iron, the magnetic field lines will be more easily guided through the core, resulting in a stronger magnetic field and more torque. A fourth way to increase torque is to use a split ring instead of a horseshoe-shaped magnet. This allows you to double the number of magnets you have, resulting in twice as much torque. All of these methods are used in real life to increase the torque of a DC motor. Thank you very much for watching, and I hope you learned something new. If you enjoyed this video, consider subscribing. It really helps me out a lot. If you have any suggestions for future videos, leave them down in the comments below. Thank you very much for watching, and I will see you in the next video.